Greetings of the day, dear children. Today, in today's lecture, I am going to explain you about the cubes and cube roots, which is there in the 8th class NCERT textbook, 7th chapter. So, the cubes and cube roots. So, to understand this chapter and to do the problems a little bit quickly, what you can do is you have to memorize first of all these cubes and cube roots at least for the first 10 numbers. Okay, so now that is 1 cube is 1, 2 cube is 8, 3 cube is 27, and 8 cube is 512, 9 cube is 729, 10 cube is 1000, all this. Apart from these cubes, you need to remember what is its units place also. If you memorize these units places also, then you can, your problem solving method will be a little faster. Okay, so the units place is 1 and the units place is 4, means it is 4 cube is having units place is 4. Units cube, the units place in the 6 cube is 6 and 7 343 is 3. So 9 cube is 9. So what you can understand is first units place you have to memorize in the cube of a number. Now let us come to the cube roots. What is meant by the cube root means you have to take the, once you got a cube, 2 cube is 8. So cube root of 8 is 2. In the reverse way, cube root of 343 is 7. Cube root of 729 is 9. Like this you have to memorize these also. Now this is what the representation of the cube root. So if you just write down the square root like this suppose, then it will understood that we can understand that it is only the square root but not the cube root. Suppose if you want to write it as a cube root, you must write what is there in this. Suppose it is 5th root, you have to write 5 in this group. If it is 7th root, you have to write 7 in this group. So now how to represent the cube root means this is what the representation. Now to do the problems little faster, you just try to understand the concept here, that the observations here are when you take an even number, then its cube is also an even number. If you understand here, the 2 is an even number, 2 cube 8 is also an even number. Take 6 as an even number, 216 is also an even number. Examples of 2, 4, 6, 8 and of course 10. All of them are even numbers. The same story even for the odd number also. If you take 3 as 3 is an odd number, 1 is an odd number, whose cube is an odd number again. 5 cube is an odd number, 7 cube is an odd number, 9 cube is an odd number. These are the important things you have to understand and observe and keep it in mind while doing the problems. So these and cube of an odd number is again an odd number. Cube of an even number is again an even number. Now cube of a number consisting of 1 0 suppose, definitely you will have 3 zeros in the cube of the number. Try to understand and memorize these concepts here and analyze so that it will be easy to do the problems. Now I am entering into the exercise of the chapter, which are not the perfect cubes in this particular following numbers. So 216, of course it is very much clear, it is 216 is the cube of 6. So but what you have to do is, if you are remembering well and good, but in the examination how you are going to write down this as the, whether it is the cube, perfect cube or not, means you are going to do by using the technique of prime factorization. So now here there is 16. So let us now start with 2 only. So 2 1s are 2 and 2 8s are 16. Why I am writing 0 here? Because we are taking at a time 16. Now again it is 2 5s and 2 4s. And again 2 2s and 2 7s. Now again 3 times of 9. Again 3 times of 3. Again 3 times of 1. So that gives you that 216 is given by 2 3 times has come, 2 cube and 3 times has come. So now it's a combination of 2 cube and 3 cube. Therefore 216 is 2 into 3 the whole cube. So that means it is 6 cube. So it is understood that 216 is a perfect cube. Okay. So this is what the way to do the problems. Now let us take 218. 218 means, again let us do with 2. 109. Again this 109 is a prime number. it cannot be done. So 2 into 1 0 9. So it is not a perfect cube. It is understood. Now coming to 1000 you can write it as 10 cube and do like this the prime factorization. You can do this one. And what is 100? 100 is having zeros, two zeros only. Definitely it is not a perfect cube. Now let us now see 46656 whether it is a perfect cube or not. 46656. So now how can you write this as? Now try to understand prime factorization when you are doing for the bigger numbers like this of 4 or 5 digits like this. Suppose you can do with any number which is possible to divide here. That means 56 is there. We know that by using the multiplicity of the condition for 4, it is 56 is divisible by 4. So you can directly divide by 4. Later when you do the expression, you can write 4 as 2 square because we are doing the prime factorization. So now 4 1s are 4, 4 1s are 4, 26, 4 6 are 24. The remainder is 25. So 4 6 are 24. The remainder is 1, 4 4s are 16. Again you can do by 4 because there is 64 is a multiple of 4. So now 4 2s are 8 and then 36 means 4 9s are 36, 4 1s are 4, 24 means 4 6 are 24. Again there is 16, so I can divide, it is divisible by 4. So 4 7s are 28 and 11, 4 2s are 8 and 3, 36 means 4 9s are 36. Now you see the divisibility for 3, 7 plus 2 plus 9, that means it is 18, it is divisible by 9 also. I can later write this as 3 square, okay. So it is 9 8s are 72, 9 1s are 9, again 9, again 9, one time. So now how can you express this? 46656 can be expressed it as 4 cube times of 9 cube, or else 4 multiplied by 9 the whole cube. So that means it is 36 cube. So it is understood that 46656 is also a perfect cube. So this is what your first question in the chapter 7.1. Now let us go to the second question. Find the smallest number by which each of the following. Find the smallest number. Find the smallest number by which you have to multiply to get a perfect square, which can be multiplied to get a perfect cube. So now let us start with the problem. The first one in the second session is 243. Again, like prime factorization only you do. 2 plus 4, 6 plus 3 is 9. 9 is a divisible by 9. So I can directly do by 9. So 9 2s are 18. 63 means 9 7s are 63. Now again 9 3s are 27 and 3 1s are 3. So you can write 243 as 9 into 9, that is 9 square, multiplied by 3. What do you mean by 9 square? Means 3 into 3 the whole square into 3. Correct? So now that is 3 square into 3 square into 3. So can I rewrite this as 3 square into 3 as one set actually, because I want to get always cubes of the number. So this as one set and the other set as this one. So what you can say now? 3 square into 3 is 3 cube and then 3 square. So if I just multiply by 3, for example, if I just multiply by 3, then I get 3 cube into 3 cube, right? So that's why we can say that the smallest number which can be multiplied to get a perfect cube is, if I multiply by 3, this number becomes a perfect cube. So what I am writing is, if 243 is multiplied by 3, we get a perfect cube. So this is what the way of writing in the examination. That is very important. Now let us see the second one. It is 256. So how will you do the prime factorization again? 56 means it is a multiple of 4. So it is 4 6 are 24 and 4 4s are 16. Again 4 can be done as 4 16s are 64. Again 4 4s. Again 4 1s. So what is being written? 256 can be written as 4 into 4 into 4 into 4. So I can take as the 3 sets, 3 of 4 one set and the other is 1. So it is understood that 4 cube into 4. So how many more 4s if I multiply? I get the cube, perfect cube. I have to multiply with 2 more 4s, right? So 4 4s are 16. So therefore, if 256 is multiplied by 16, this is the smallest number by which you multiply, we get a perfect cube. We get a perfect cube. I hope you could understand this. So let us now see the third one in this exercise. The number is 72. I hope you can do 72 means again 9 8s are 72 and then 4 2s are 8, 2 1s are. So you can write 72 as 9 into 4 into 2. But let us do this in the prime factorization. Like 3 into 3 is 9. 2 into 2 is 4 into 2. I hope you are able to understand. I am writing this 4 as 2 into 2. I am writing this 9 as 3 into 3. Writing this 2 as a single one. Now what is observation here? I am able to get 2, how many times? 3 times. And 3 I got only 2 times. So if I multiply with 1 3, I will get a perfect cube, right? So 72 is multiplied, if 72 is multiplied by 3, is multiplied by 3, we get a perfect cube. We get a perfect cube. So this is what the understanding of the problems. So now let us go to the next problem. What is that? That is 675. So again 675 means 5. With 5 you can do, right? So 5 1s are and 5 3s are and then 5 5s are. Again 5 2s are and 35 means 5 7s are. So now it can be done with 9 3s are 3 1s. So now we can write 675 as 5 multiplied by 5 and 9 multiplied by 3. Now we are doing in the prime factorization. Now to save the time I am actually dividing with 9. But when you are writing like this, again you can split this as 3 into 3 as 9. So that then only we can get the sets now. So the set is now 3 into 3 into 3, one set I got, and 5 into 5 only one set I got. So if I multiply with 5, then I get a perfect cube. So therefore, what is the number? The number to multiply is 5 to get a perfect cube. To get a perfect cube. This is what the way of style of writing in the examination. And then coming to the next problem, the fifth one, it is 100. 100 cannot be a perfect cube. So now 5 and 5 2 20s and then 4, again 4 5s, again 5 1s. So now what we got here? 5 into 4 into 5, that can be written as 5 multiplied by 2 multiplied by 2 multiplied by 5. So there are only 2 2s and 2 5s, correct? So what you can do with 1 5 and another 2. So 1 5 and 1 2, if I multiply, I get a perfect cube. Therefore the number to multiply is what? Number to multiply is 10 to get a perfect cube. To get a perfect cube. Is that clear? So with that we have done with the exercise, the bit of 2 in exercise 7.1. Find the smallest number. The next one is, the third question in this is, the smallest number by which each of the following numbers must be divided to get the perfect cube. So in this one, it should be 81 now. 81 means again doing by 9. 9 nines are 81, 9 ones are 9. So therefore 81 can be written as 9 into 9. So but you can have to write as the perfect, the prime factorization, right? So 3 into 3 into 3. Now how many sets we have got? I have got 3 sets, right? Here, and there is 1 set. Now the question is to divide. So the number to divide is what now? The number, if I divide this by 3, I get a perfect cube. The number to divide is 3 to get a perfect cube. To get a perfect cube. So I hope you could understand. In the previous exercise, it is the number to multiply. So with which you multiply, again extra numbers you will get. Whereas here, with which you want to divide, means this 3 you have to divide so that you will get a perfect cube. Let us now go to the next problem to see the which number you have to divide. I am taking now 128. So now it is 4 3s are and 4 2s are. Again 4 8s are 32, 4 2s are 8, 2 1s are 2. So you can write 128 as 4 into 4 into 4 into 2. So this is one set again. 4 3 times is one set is over. So if I divide with this 2, then definitely I get a perfect cube. So the number to divide is what? The number to divide is 2 to get a perfect cube. To get a perfect cube. So like this you can solve the problems. And now let us have another question. What is the third one is? Third one is 135. So again it's a units place is 5. So it is divisible by 5. So 5 2s are 10, 5 7s are 35, 9 3s are 27, 3 1s are 3. So now you can write 135 as 5 into 9 into 3. So it is 5. 9 can be written as 3 into 3 into 3. So therefore, how many 3s are there now? 3 3s are over. The extra is what? 5. So the number to divide is 5. Okay. 5 is the number. 5 is the number to divide to get a perfect cube. Okay. Now let us go to do the next one. The fourth one is 192. So that is 2 1s, 2 9s are 18 and 2 6s are 12. Again 96 is a combination of 4 I can do. It's a 4 divisibility you can see. 4 2s are 18, 4 4s are 16. 4 4s are 6. 4 2s are 8, 4 4s are 16. And 4 6s are 24. And then 3 2s are 2 1s are. So it is 192 can be written as 2 multiplied by 4 multiplied by 4 multiplied by 3 and 2. So that is 2 into 4 means 2 into 2. One more 4 means again 2 into 2. One more 3 and one more 2. So there is a set of now 3 2s here. And again there are 3 2s here. 3 2s here. And extra is 3. So what is the number to divide? The number to divide is 3 to get a perfect cube. Let us now have the last problem in this exercise. 5 is 704. So the last 2 digits is 4. So it is divisible by 4. So 4 1s are 4. 30 means 4 7s are 28. 24 means 4 6s are 24. Now 4 4s are 16. Again 4 4s are 16. And 4 11s are 44. 11 1s are 11. Correct? So 704 can be written as 4 into 4 into 4 into 11. So it is very much clear that there is a set of 4, 3 sets of 4 is already there. And extra is 11. So the number to divide is 11. So this is what you should understand. And now let us go to the last problem in this exercise. The fourth problem is Parikshit makes a cuboid. I hope all of you know the problem, a cuboid. So I just write down the dimensions of the cuboid. The dimensions of the cuboid. So what are the dimensions of the cuboid? It is 5 centimeters, 2 centimeters and 5 centimeters. So how many such cuboids will be needed? So now when you have a cuboid, what is the volume of a cuboid? Length into breadth into height, correct? So 5 into 5 into 5. Now if I multiply with how many more, I will get a 3 set combination. If I multiply with the 5 again, if I multiply with the 2 2's, because I have 1 2 only here, I have 2 5's, correct? So if I have 1 5 and 2 2's, then my job will be done, that it will be a cube, correct? So therefore what you can say, 5 into 2 into 2, that means 20, correct? So if 20 cuboids of such type, cuboids, or if 20 cuboids are added, it forms a cube. It forms a cube. So how many such cuboids are there to form a cube means you have to see how many more are there now to make it as a perfect square. So this is what you should do to complete the problems. With this we have done exercise 7.1 in this lecture, in this video. I hope you could understand well. Dear students, I will do with the next trick is how to find out the cube root in my next video. Thank you so much. Wish you all the best, my dear.